This is lesson 6 of chapter 7, the last lesson of the chapter. And in this last lesson, we will learn how to name acids. Now, acids are a very special class of compounds in chemistry. And acids, what they are essentially is kind of an ionic compound, except the cation, the positive ion, is made from hydrogen. So, for example, a few examples are hydrochloric acid, which is this acid, which is HCl, and sulfuric acid, which is H2SO4. We will show you how to name these and how to form them. Now, acids have H, hydrogen, as an active ingredient, and hydrogen takes the place, essentially, of your metal. Remember we said that hydrogen is actually placed with the group 1 metals, here's hydrogen, because it has chemical properties of metals. So hydrogen is not a metal, but it acts like a metal. One of the ways it acts like a metal, you can say, is it forms compounds that produce ions. In this case, hydrogen, whenever it's with some kind of nonmetal. So the Cl then is the nonmetal. So again, these are formed between H plus and Cl minus. That's how this is formed. In this case, we have a polyatomic ion, SO4, which has a -2 charge, and that is why we have 2 hydrogens balancing it, because each hydrogen is +1 since it is in group 1 of the periodic table. So this is again kind of a mixture of ionic and covalent for acids. So we will show you how to name these acids. Acids are a very important class of compounds in chemistry. Every chemistry laboratory not only has them, but probably uses them every day. So very important compounds. We will, just as a note, we will spend a whole entire chapter learning about these acids this semester. Okay, so first of all, let's distinguish between what are called binary acids and oxy acids. So binary is actually this guy right here, and binary because you only have 2, hydrogen, and just 1 other element. And then oxy acids, you can probably guess from the prefix oxy, these are the ones that have oxygen in them. And in fact, they're based on polyatomics. So your famous oxy acid is sulfuric, this guy right here. And incidentally, this is my favorite acid, if you wanted to know. Sulfuric acid is my personal favorite acid. So here are the rules for naming them. For binary acids, the rules, again, binary are made of a hydrogen and a nonmetal. The rules say you put hydro in front of the name, and then the nonmetal, and then the ending ic, and then the word acid. So here's hydrogen, here's the nonmetal. You say hydro for hydrogen, here it is hydro, and then chlorine becomes chloric. So the ending is changed to ic. This ending ic essentially tells you that you have an acid. If it was just a regular ionic compound, you would say chloride, like sodium chloride. But in this case, it's an acid with hydrogen, so you say chloric. And then at the end, we put acid just to designate it as acid. So hydrochloric acid. You have heard this term. Now you have the rule for naming it. This is for binary acids. The second type of acid then is, we said, the oxy acid, and here are the rules for naming oxy acids. To name, you have polyatomics in these oxy acids. They're made of hydrogen and a polyatomic. That's why they're called oxy acids. There are 2 basic rules. There are 2 types of polyatomics. Now, you will either add ic to a polyatomic, or you will add os. This allows us to go a little deeper into polyatomics. There are some polyatomic ions that we haven't shown you yet that we'll have to use for these acids. If the polyatomic ion ends in ate, which is the type that we've seen, in fact this right here is sulfate, then the ending becomes ic, just like the previous slide. However, if the polyatomic ion ends in ite, which there's a bunch of polyatomic ions ending in ite, the ending becomes os. So this is actually new information right here. And we'll show you a bunch of examples of this. So the example here is used to have sulfate as the polyatomic ion. So it becomes sulfuric. Now, you'd think that sulfate would become, the 8 will become ic, so you'd think it becomes sulfic. And if you put sulfic, I would probably give you full points. However, in this case, they decide to keep the R just so it sounds like you're based on sulfur. So actually, they extend this by saying sulfuric acid. And if you had sulfite, there is a polyatomic ion named sulfite with an ite ending. Sulfite, by the way, is SO3, 2 minus. If you had an acid based on this, which would be H2SO3, you would name this as sulfurous acid. Sulfurous acid. So the ates becomes ic, the ites become os. That is really the big rule. Notice one more thing, you do not add hydro in front. On the previous slide you had hydro, so you had hydrochloric acid. Here we do not add the hydro. If you have a polyatomic ion, the hydro is not used. And that is just a part of the rule. Okay, why don't we try a bunch of these, and then we'll see if we can make sense of them. So here we go. We have, really we should have a binary acid. Let me enter one more example problem. Let's do this. Let's put HF in here. We'll actually begin with this one. So we're adding to your notes. So HF. Now HF is a binary acid. The reason I added him is because I don't have any binary acids in here. So binary acids would use the prefix hydro, so you'd put hydro, and then fluorine becomes fluoric, hydrofluoric, and then at the end you put acid. So really hydro for H, fluoric, and then acid. Now for these oxy acids, you will not use the hydro. In fact, you will simply use the ic. So this polyatomic ion, remember, is called nitrate. And nitrate becomes ic, so you got nitric. Simple as that. So nitric acid. Notice no hydro because you have a polyatomic. This is phosphate. This polyatomic ion is phosphate. And so phosphate becomes ic. Now, instead of saying phosphic, it's the same as sulfur. We're actually going to keep the R, phosphoric. So we'll say phosphoric acid. So we're introducing a few exceptions again. So phosphoric, if you mess that up, if you don't put the R in, I'll give you full points. But after you have practiced these, you'll find that phosphoric is the way to say it. Now this last one is actually not nitrate. Nitrate is up here, NO3. This is nitrite. And this is a cousin of nitrate. So the rule said that ite becomes os. Ate became ic, remember? And ite becomes os. So in this case, you would call it nitrous acid. Nitrous acid, with the ending being different. This I know is probably much more confusing than probably one of the more confusing versions of it, but try to read over it again, think through it again, and practice a few more on your own, and we will practice together in class. So this completes for us not only the 6th video, but the whole unit, which was kind of short, of Chapter 7.